Let's take a look at some of the software tools you can use to interact with the grid. Note for MOOC participants, for this course you will not use the remote access to a user interface machine, you will use the course virtual machine instead in place of the grid UI. This means that the following tips apply only to those who have already acquired a user interface account from their local NGI. When following the examples below, remember to replace your personal username and the user interface host name whenever required. Okay, let's start. The general requirement for accessing a remote machine from your laptop depends on the operating system of your local machine. For an interactive connection to a remote machine, we will need something like SSH or PuTTY, and for transferring files to a remote machine, we will need SCP, or if you prefer a graphical interface, you can use tools like WinSCP, FileZilla, or CyberDuck. Mac and Linux users have a slight advantage, as many of the needed tools come with their operating system. We will now show the tools to set up a remote connection. So you can access the grid infrastructure using a UI machine. To connect to the UI, you will need to secure terminal program. This means that you will first install an SSH client. We recommend you to use one of two such clients, depending on the operating system of your computers. Linux and Mac users will not have to install anything. The SSH client is already on board. When you have your UI account, you can try it from your local machine or VM by typing the phrase as listed above. Windows users can install PuTTY, and PuTTY is a screen-based SSH client which allows you to log in the same manner as Linux and Mac users do. Basically, you have to fill out the server address and your own credentials to be able to log in to the remote machine. So let's give an example of how this works using a screencast. So to log into the UI machine, you use SSH, and SSH has a nice parameter, the -x, which allows you to also run graphical applications on the remote machine while being visualized locally. So here we log in using the MOOC user and give our credentials. So let's just see what is already in there, and it's just a desktop folder. We create a hello world script, or just hello.sh, and edit it with nano. Here we can just type anything we like, and in this case we will make it print hello grid. Save it and just see again what we just typed. Now we need to change the execute parameters of this file. We allow users to execute the file so that we can see the print statement, and there you have it. And now we just close the connection and we're back on our own machine. So we also need to be able to transfer data from your local machine to the UI. We will show you with some commands how to do this using the command line. Linux and Mac users again do not have to install anything, as SCP, the application used for transferring the data, is already available. So to try it, use the path listed there, so the SCP command. For Windows users it's a bit more involved, but you can for example install WinSCP to transfer data back and forth from the remote machine. This just allows you to drag and drop a file. So other applications are available as well. These include FileZilla and CyberDuck, and there are many more. And there's tutorials online on how to use them. So to transfer a file using SCP, we just give this small screencast. So SCP is just as we have listed in the previous slide. We're going to copy the gridpy.c program to the remote machine, which is our user interface machine here at Surfsara. So again, give the same credentials as we've done before. Basically, let's log into the machine to inspect what we've just transferred. So there we go, we're logged in, and as we can see, the gridpy.c is now available. And let's just inspect it to see what we're doing. So this is one of the examples that we'll use during the MOOC. This is a C file that illustrates a Monte Carlo algorithm to estimate the value of pi. The algorithm is described in the comments inside the script. Inspect the algorithm, modify the number of iterations if you want, and then run the program. So GCC, the compiler used to transform the source code into an application, is already installed on the VM, and you can use the command as we're showing now to transform this application from the source code to the application. Just run the application and see the result. So as we can see now, we have the GridPy application without the .c extension, and let's run it. And as you can see, we have an estimate for the number pi.